So, in my term project, I just want to uh, quantify the water balance, to be particular at the sprinkler irrigated field in Boxelder County, Utah. And for my for my term project, I just choose one of the fields, sprinkler irrigated fields in the Fielding, Utah. And just like the way we did. So, water balance helps to schedule when to irrigate and how much to irrigate, yeah, in a certain field, just to increase the irrigation efficiency. So, irrigation efficiency and the crop yield for the better production, because the ag water management optimization is one of the pressing topic in the Western United States. So, uh, the managing the ag water by the irrigation schedule is one of the uh, good thing, and for the ag water management, and for because there was no near U aggregate station just near the box center county. So what I did, like, I choose the one in the Preston, Idaho, for the station, and it's the U aggregate station. So I did just the like we were taught in the class, and I just try to quantify the ET, not just by the simple ET that's mentioned in the class. I just uh, I wanted to go over the different models that's in the OpenED, just like the metric ones, and also use the FAO 56. So I also quantify the precipitation and water balance, especially in the sprinkler irrigated field, and the field is of alfalfa in the Box County area. So what I did, like, okay, I choose the field that's in the Box County, but it didn't have access to the U aggregate station, so I had to choose the one in question that's available, and so I'll use the opportunity just to choose the polygon and run the time series on it. And I use the USDA Web Soil Survey. So this is the field that I used just to get the water balance, ET, and precipitation. And it's showing like the majority of the texture of the soil is like the silt loam, and I ended up using the field capacity, command and wilting point, and yeah, and such type of the parameters while using the water balance. And I got this figure of the ET. So it's taken from the 6/8 2023. So what I did, like, I just went through the freezing dates, and after the freezing dates, I just gave some days after and just took the data all the way from until the 9/20/28. And you can see uh, the KC is the one that's going on the top. That's the coefficient. And at the same time, I used metric ET, SSCB, SIMS ET, PT, JPL ET, and GAFL 56 for quantifying the actually that transpiration uh, in the alfalfa irrigated box Taylor County, Utah. And this is the precipitation. So the orange one is just like the flat. That's the straight one. It's because when I just try to download the data from the US Climate Center, so the precipitation, there was no any precipitation data, there was just zero. So that's why it's showing straight. But the one that I got from the climate toolbox is just showing like there's one, it's going up, and the grid made and the USU climate center precipitation is being compared on the flow charts. It's like this. And so it's the water balance from the instability. And the one on the top is just like showing the field capacity, wilting point, soil moisture, and the one on the bottom is just showing the applied irrigation and rainfall, the red ones, and the lost ET with the orange ones. So and this one just shows the accumulated ET with the red and accumulated irrigation and precipitation applied with the orange one. So I got the same, I got to use the same water balance by using the different model like the E metric from the OpenET. And there's a quite difference between the two, especially in the accumulated irrigation and precipitation. And I also use the SSE pop, another model from the OpenET. So the figure also looks quite different, especially. And I also use the SIMS model, another model of the OpenET. So basically, what's more differentiating is like the accumulated irrigation and precipitation, the orange one. And likewise, I also use the PT JPL model from the OpenET and and the one from the FEO 56 by quantifying the crop coefficient and the potentiality from the Utah Climate Center and this the actual ET after multiplying the crop coefficient and the potential ET. So that's the final result. And I was able to compare the ET from the Insevel ET FEO 56 E metric as a big of SIMS and PTJPL. And what I found live, I found there's you gotta forget it's supposed to be able to. So FEO 56 is supposed to be getting the more efficiency. It's I suppose it's 82% right. So there's some and uh, and the two models like E metric and the SSE BPOP is getting more efficiency than the SIMS and Singulity. So the second two is just like comparing the efficiency between the instability and all of the charts and the columns is comparing with the instabilities. And from the water balance worksheet, I just got to know that the irrigation system capacity or needed is like 4 inches, or so it means the 192 nm. So I tried to use the different available model from the OpenAT in the specific site in fielding of box under Utah. So because I didn't find the nearest weather station, so I just used it for my town project from the one in Preston. So so these are the results, and it's showing like I'm just getting the more, other than the FEO 56, and the model that I'm getting the more efficiencies from the metric than the one from the disability. So, so various methods and models are available for calculating the ET and the water balance. So I think it's better to choose the one who has the very less errors. Thank you.
All right.